All right, so let's talk about graphing secant and cosecant. I think this is going to feel a lot easier for us just because it really does stem right from the sine and cosine graphs. And let's see why. So first off, we know that cosecant is, oops, what happened to my marker? We know that cosecant is 1 over sine, right? So this on the graph right here in this dashed line is the sine graph. So if I think about 1 over sine, and anywhere that my graph is at 0, 1 over 0 would be undefined. So anywhere where my graph is at 0, I'm going to have an asymptote here. Okay. Also, we know that anywhere where my graph is at 1, 1 over 1 gives me 1, right? So those points will be the same. If I have 1 over negative 1, that's going to give me negative 1. So notice that these points here are the same as the sine graph. Now, if I think about where is my sine graph 1/2, that would be at pi 6. And if I have 1 over 1/2, that's going to be pi 6 2. And then same thing here for this value. And you can think of that in terms of, looking at our sines as well. So from there, it's just connecting these dots. You'll notice that it kind of looks like it has this parabolic shape, although this isn't a parabola because it would have to have the domain of all real numbers, which it doesn't. So just get closer and closer to the asymptotes. But yeah, this is what our graph of the cosecant looks like. Again, it's the same as the sine graph in terms of where our points are. 1, 2, 3, 4, and then anywhere that where it was a 0 is an asymptote. So just so you guys know, I wouldn't expect you to have to graph these points exactly. It's really these main points, which will be like the max or min of, I don't know what you want to call these, big parabolas. And then you'd also want to be able to graph the asymptotes. So let's talk about these characteristics. Amplitude is listed first. Well, it's probably easier if we do domain and range. So our domain is all real numbers except, you'll notice that our first asymptote starts at 0, so x can't equal 0, plus anything that goes by an interval of pi, which I could have just written pi n, but I just write 0 just to try to confuse you. For our range, now notice it's going to be negative infinity to negative 1, union 1 to infinity. That's a parentheses, just so you know. For our amplitude, now remember amplitude is half of the range, and since this is technically an infinite range, that doesn't exist. And last but not least, period. Well, remember, when we're talking about period, we're talking about one complete cycle. So here it would be one complete cycle. How long did that take? That took 0 to 2 pi. So the period here is 2 pi. Okay, so again, just to reiterate what I would expect you guys to graph, it would be the asymptotes, bottom and top, and then also just to have the correct shape of the graph. Okay, so secant. Remember, we know that secant is 1 over cosine. So just like last time, anywhere where our cosine was 0, we're going to have an asymptote. Okay. Anywhere where cosine is 1, 1 over 1, we're going to have 1. Anywhere where cosine is negative 1, we're going to have negative 1. And also similar last time, which although I don't really grade based on this, wherever it would be 1/2, actually it would be at 2. 1 over 1/2 is 2, same thing with the negative 2 here. But again, you're not expected to have to graph those perfectly. And then from there, you just want to make sure you have the right shape. Okay, so cosecant and secant graphs look crazy similar. It just has a shift, which is similar to the sine and cosine graphs. All right, so let's go ahead and fill in these characteristics here. Again, I'm going to go out of order of what's on here. My domain is all real numbers except what can't x equal? we'll find your starting asymptote, which I'll just start with pi over 2, whatever. Pi over 2 plus, what's the distance between these? It'll be pi, so pi n. Our range, similar to last time, is -infinity to -1, union 1 to infinity. Our amplitude would be half the range, but that's not possible here. And last but not least, our period here would be 1 full cycle. So here would be 1 period. Oops. And that is 0 to 2 pi. So the period is 2 pi. Not to be mistaken with 2 pi. Okay, so of course we have some strategies for graphing cosecant and secant. First we want to find all info as if it were sine and cosine, and make sure that we plot our points just like it would be on sine and cosine. Then we're going to draw our secant and cosecant asymptotes. And last but not least, we're going to fill in the curve. Okay, so those are our graphing strategies. So I'm going to work with the first one with you guys, and then I'm going to have you guys pretty much just try the rest. So let's take a look. We're going to graph 2 periods of the following secant equation. Let's start with identifying our information here. Here we have a vertical shift of 2. Our A value is -2. Our horizontal shift, remember to do that, we set this part equal to 0, so we get x equals 0. Period, we know that we're going to do 2 pi divided by the B value, which in this case is 3, so it's 2 pi thirds. And last but not least, to figure out, that was weird, to figure out the intervals, we're going to take our period and divide it into fourths. But that's going to be 2 pi over 12, which is pi over 6. Okay, so let's draw our axes here. So I'm going to have this, and this. Okay, let's start, since we have a vertical shift of 2, right away, and I'm going to, here, let's do this. Right away, I'm going to make that new ground base at 2. This is 2. I'm going to go up to 4, and then it would be back at 0, right? 2 away. Down here on the x-axis. So just as a review, we know we're starting at 0, and I'm going to be pi 6 away every time. So this is pi 6. I'm going to have 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Oops, by the way, when I did that, it's hard to do 2 things at once. 5 pi over 6 and 6 pi over 6. 7 pi over 6 and 8 pi over 6. Okay, I hope you guys know that I'm not writing exactly what I'm saying just because I want you to know where these are coming from. Okay, finally, let's put our points in here. So if this is the reciprocal of cosine, well, cosine I know would normally start at +1, but because it's got this negative in front, I actually start with -1, but since I have the vertical shift and this little stretch here, I'm starting at 0. And I'm just going to kind of fill in the points just like I would for a regular cosine graph. Okay. Remember, that was part of our graphing strategies. Next is I got to figure out, okay, well, where are my asymptotes? Okay, well, my first asymptote here is going to be at pi over 6. And because of my period here, the next one's going to be a pi over 2. anywhere where it was at on this axis here is where I'm going to have that asymptote. Last but not least is I'm going to fill in this curve or the shape. And voila. Okay, let's have you guys try this one on your own. Go ahead and put me on pause. All right, so gray's ugly, so let's change it. So I figured out that A was 3, vertical shift to -4, horizontal shift I start at, oops, ignore that, x equals negative pi over 4. Period is pi, and the intervals are pi over 4. I started just by setting it up, okay? So see if you're able to set it up correctly. That vertical shift really impacts where this ground base is. Next, because it's cosecant, I have to think about it in terms of pi, right? So here, I am going to start at quote-unquote 0, but in this case, 0 is like at -4. And I'm just going to fill in my curve. But anywhere that I had it at -4, remember I'm going to have that vertical asymptote. And last but not least, I'm going to fill in the shape. I know what you're saying. You're thinking this is easy peasy. Okay, last one. Again, try it on your own and then we'll check. And I'm going to have it all done by the time you're ready to check. So check. Try it on your own first. All right, so go ahead and take a minute to compare all of our information here. If you did get this correct, you should have the same graph, I hope. Or if you got the graph correct, that should imply that this is correct. So just take a look here. Notice that I did have to start down here because of the negative in front of the secant. But otherwise, it should be pretty self-explanatory.